Okay, so that kind of cracked me up a little bit because that video of the University of Florida professor. I mean, even a physics professor that's being on TV, and I'm sure they edited that a bunch of times, still said for every action there's an equal and opposite reaction. Well, that is not true, and that's not what the textbooks say. But that's what we all say. So you got to be careful with that. All right. Um, University of Florida, chop. Anyway, so let's go back to my skaters here real quick, and I'll get me out of the. Whoa! Now I'm recording me, and I don't want to do that. Um, well, I screwed that up, so let's go ahead and close this part. And we're still on the screen, so that's good. So you got me, and that was probably a little more clicking than you needed to withstand. Um, Let me turn back on the ladybug here. I want the lamp to come on, so then I'll click on ladybug. Once I get the blue light, the lamp is on. All right, so there we go. So now, here she comes. Sorry for the delay. Okay, now, so where were we? We saw that minus 100 newtons. Let's go back to our ice skaters here real quick. One was pushed with one. The young woman was pushed. Mass one was pushed this way at minus 100 newtons. Okay, but if you look at their magnitude, and mass two was pushed this way with 100 Newton force. Let's say that the acceleration of 2 was equal to, let's keep the math simple, 1.0 meters per second squared. Okay? All right, so force is on 2 was equal to 100 newtons positive, which is equal to his mass, which was 65 kilograms, times some acceleration. So we take 100 newtons, again, divided by the 65, and we find out that his acceleration is equal to 100 divided by 65, drum roll please, 1.54 meters per second squared. Notice he had a change in speed. And as long as she's pushing, as long as he's accelerating, he's gaining speed. He's gaining 1.54 meters per second squared. If the push lasted for an entire second, he would be going 1.54 meters per second at the end. That would be his final velocity. We'll get into that stuff a little bit later. But let's look at mass 2 real quick. Minus 100 newtons is equal to mass of 1 times the acceleration of 1. So since we know that this is minus 100 newtons, because for every action there's equal and opposite reaction, we get 45 kilograms, which is always positive. Mass is always positive, times A1. Now look what happens. We take minus 100 newtons divided by 45 kilograms, and lo and behold, I've got negative. Oh, I was going to do it with 90 newtons earlier, divided by 45 is equal to negative 2.2 meters per second squared. So she's really going to take off a little bit. I mean, she's going to get going pretty good. But once they stop pushing on each other, if it's a frictionless ice, we're going to assume friction, they're going to keep going at that constant speed forever. Once they stop pushing, once the force goes away, I want to make sure that you understand that part. Okay? So we're just wanted to elaborate on that a little bit. Okay? All right. We are done. Oh, sorry. Oh, sorry.